Hello, my name is Robert Holzhauser, uh, and for my graduate project, fall 2020, what I did is I created a approximation to some extent of the famous Asteroids game from the 1980s, and I called it Asteroids-ish. Functionality is not 100% there, but it's approaching asteroids. It's kind of cool. I use the HTML canvas. So first off, I'll do a little demonstration of the functionality that I have. So all the asteroids are circles of a random size, and you can see that when the ship collides with the asteroid, that the asteroid resizes a few times, and every time that it collides, it gets a score. So there's, we can shoot also. You see the bullets, and notice the bullets are flowing through all the way through the screen, and then after a couple of seconds, after 3 seconds to be exact, they disappear out of the array as well. And so there's also, we can move the ship, and we can go backwards. And so that kind of approximates the way that the Asteroids game from the 80s moves. One thing that's a little bit wonky still is my rotation. I haven't quite got the rotation of the ship, but we're getting there. So let's look at the code. So the HTML really is pretty simple. I just have a title. At the top of the game, I have a div that includes the play button, the score, and the level, which are each referenced with the score has a separate span, and the level has its own span to make it, each of those have their own IDs to make it easy to write to. Then define the game surface. So there's a div that I put the canvas in. I set the parameters, the height and width of the canvas here. The CSS, I initially started to go down the path of doing this not in the canvas, but just in HTML. I decided that it would be a lot cooler to do it in the canvas. So I do have a little bit of CSS that's left from that. But the main thing that's defined here in the CSS is the play button and, of course, the canvas. And that the size matches what's in the HTML. And we add a little padding so that it's not right up against the side of the screen. Most of the magic happens in the JavaScript file. So of course we use strict mode. Then the whole game is a self-invoking function. With Windows on load, we define the score variable initially as 0 when we start. Game state as ready. Well, I haven't quite implemented the lives yet. This is looking towards having lives with the default number of 3. We start with on level 1, and the level controls how many asteroids. So how many asteroids get put into the asteroids array. When we start, we go ahead and set the play button to show. While it was playing, it gets toggled to being invisible. So it's only visible when we first start or when it's reset to show. And then we write the score and the level here initially and set up a listener using jQuery so that on click, we're gonna toggle the game state from ready to playing. And then we're also gonna toggle the visibility of the play button make it invisible. We're going to generate some asteroids and start playing. So then we have our canvas, which is set up. We get our context. Then we have some listeners. So we've got the space bar, which shoots. We've got our arrow up, which accelerates, our rotate left and right button, which still need to fix the implementation of those because it rotates the entire canvas as it currently is. Just want it to rotate the ship. Arrow down does a reverse acceleration or kind of braking. And then the escape button to stop playing. So one of the first things we do is we define how to draw the border, which is just a line around the canvas. So for the top border, we start in the top left and go to the canvas width. Still with the Y still at 0, draw that with the stroke. Same thing for the bottom, so we start at 0 for the X coordinate and make the Y coordinate for the starting point, the bottom left, and then go all the way across to the full width of the canvas with the same height, which is the height of the canvas, draw that line, and then repeat the similar operation for the vertical boundaries, starting again in the top left to draw the left border, drawing down across the left side from the top to bottom, which is the height of the canvas, and then repeat on the right side, starting with the X coordinate at the full width of the canvas in the top and going all the way down to the far right-hand corner and drawing that. So that gets us our boundaries right here. Then we have some different objects that we're using. We're using an asteroid object. And with the constructor for the asteroid object, we get a random value for X, a random value for Y, a random size for the radius. We default the color to gray and then have it start moving at the level times 1.1. So that's the speed, defines the speed of the asteroid movement. This ID makes it easy to then clean up the asteroids array for each asteroid and take it out of the array. And then this .show makes it easy to track whether or not we should redraw. You can see here in the draw asteroids function, it only draws it if the show is set to visible. And of course, that's the default state, is that the asteroid is visible when it starts. Then we just draw a circle, the asteroids are a circle, and we plug in these random values that we got here for that. So we draw our asteroid there, and then with the movement, the asteroid movement is such that it's going to bounce off of the borders of the asteroid. And we're going to set the position each time that we are iterating through here and calling the move function. We reset the position to the current X or current Y plus the X and Y velocity. Now, when the asteroid crashes, that's a good thing, so we're going to increment the score. And then we're going to cut the size of the asteroid in half. As long as it's not too small, we're going to redraw it. If it's too small to be very much fun to play with, then what we're going to do is we're going to mark it for invisible, and we're going to clear it out. Just clear the level. One of the things it does is it loops through and it clears out any asteroids using the splice function that are not, that have a show set to 0. So that's what happens when an asteroid crashes. Then we have our ship object, and we're going to initially position the ship right in the middle of the canvas, which I get by dividing the x and y coordinates by 0. And we give the ship an initial velocity. You can see when we first start that the ship is moving a little bit. So that's our initial velocity. It has a decay when it moves, so it slows down pretty quickly. And the ship is a triangle, so we're just going to draw a triangle with the size of 25. And then we're gonna, the rotate function, again, it currently rotates the entire canvas, so we need to figure out how to isolate that just to the ship itself. The up arrow and down arrow trigger this function from the listener to increase the velocity of the ship by 0.25. But the maximum velocity, so that it stays at least mostly visible, is set to 10. And reverse is the same thing. So the maximum reverse velocity would be -10, and reverse goes just a little bit slower than accelerate, set to 0.15 instead of 0.25 for the y velocity. All right, so then with our move, the way that we can move, the move function that we apply allows the ship to go through the edge of the canvas and come onto the other side. Same thing with reverse. So that's pretty cool. So the asteroids bounce around and the ship goes from one side to the other. And the way that it does that is if it's getting basically starting to go to the edge of the canvas, so is the x at the center plus the size of the ship, then we reset it just on the inside of the left canvas. Similarly, if it's going the other way and it's less than 0, then we set it to just inside the right boundary. Otherwise, we simply increment the velocity. We increment the x position by adding the x velocity. Same thing for the canvas height. We're getting close to the edge, then we reset it and move it to just inside the top. And similarly, if it's at the top and it's starting to go off, then we're going to move it down to the bottom. Otherwise, if it's not at one of the edges, then what we're going to do is just increment the y velocity, increment the y position by adding the y velocity. Then after we've done that, we're going to slow down the speed. So whatever speed it is, we're going to slow it down by 0.1. So that way, the game has a tendency to, unless the person keeps their button on the accelerate or decelerate, we're gonna keep it kind of easy to watch, easy to see, so we can have more control over the ship. Then to shoot, what we're gonna do is create a new bullet. We'll look at the bullet objects here in just a second. And we're gonna add the bullet object to the bullets array. And we'll just add it straight away. And then if the ship explodes, haven't built out what that's gonna happen. So far we just say the ship exploded in the console. So we have a bullets array. Start off just defining it as an empty array. Then our bullet constructor, we have an x and y coordinate and a velocity, which it gets from the ship, and then it adds +3. So the bullets, upon being fired, will go somewhat faster than the ship. But still not so fast that it's not easy for the eye to follow. And again, the same idea, we track and identify the bullet in the array by just using the length of the array when it's created. And so that gives us its position in the array. And this allows us, by capturing the time that the bullet is created, since it immediately goes into play, this allows us to track how long it's been in play and to make it invisible. Again, we have a visibility toggle. So after 3 seconds, you'll see here in a minute or two that what we do is we make if we go over 3 seconds, we make the bullet invisible and take it out of the array. So when we draw the bullet is just a small circle. And we only draw the bullet, this is important, if the bullet is marked as visible. If it's marked as invisible, we don't want to draw it anymore. We're also going to clean it out of the array, but there might be a gap in there, so we want to be sure that it's set to be invisible too. So our movement algorithm for the bullets is the same basically as for the ship. So that means that you can shoot through from one edge, you can shoot through to the other side, just like the original gameplay, which is pretty cool. In terms of it's a simple formula, but in terms of a user experience when playing, I like that. I think it's fun to shoot through from one side, excuse me, and have it come out on the other side. So this is how we vanish the bullet. We get the time now, and we compare that. We get the seconds of the original time when the bullet was created and the seconds now. And if the more than three or more seconds have expired, or if the minutes have incremented and the difference in minutes is 1 or more, I don't know how we'll get to more than 1, but just to be safe, then we're gonna set with either the number of seconds difference or the minutes is more than 1, then we're going to toggle it to be invisible, and that's going to make it so that in the draw function, it doesn't get drawn. It's only drawn, a bullet is only drawn, or a ship or asteroid. Well, I don't have it set up for the ship, but the asteroid is only drawn if the value is 1, and the same for the bullet if it's 1. So then we also have here to create a new ship, create an asteroids array. With the generate asteroids, we essentially loop through creating new asteroids and drawing them. The number of times is the level. So each level we add a new asteroid. And then we're animating in our play loop down here that we'll see in a couple minutes. We animate the asteroids, which means we just move them and draw them. Same with the ship, the animate function for the ship, we move and draw. Animate here for the bullets is a little bit different. Not only do we move and draw the bullets, as we've looked at it up here, but then we also apply our time vanish to make the bullets invisible after 3 seconds. The collision detection, so I'm using one of the formulas on MDN for collision detection. And what I'm doing is I'm looping through all the asteroids, and we get the distance between the ship and the asteroid on the X and Y vectors. And then we get the overall distance with this formula to get the square root of the total of the X and Y. And if it's closer than the size of the ship, then we're going to call it a collision. Since there's a collision, we increment the score, explode the ship, and crash the asteroid. Right now, though, since the explode ship is not incremented, it's like we have a bulletproof ship or something. asteroids don't hit the ship, which also is kind of cool, which is, I haven't decided if I want to leave it that way or not. But I kind of like it because then you have, maybe I'll make it an option or something. But at this point, then it crashes the asteroid, which each time the asteroid crashes, it reduces its size in half until it gets to 10. And then when it's at a size of 10, it just goes invisible. So then, after we've checked if the asteroid has crashed with the ship, then what we do is we do an inner loop through the bullets and we check and see if the bullets are still visible. We're not going to apply this if the bullets are not still visible. We're going to apply the same collision detection formula for each bullet, although we're not going to take the radius or the size of the bullet into account. We're just going to use the exact XY vector in the distance formula. And then we're going to, if there is a collision, we're going to log it, we're going to mark it to not be shown, crash the asteroid, and increment the score, which also redisplays the score to the HTML. So play, this is kind of a critical one because this is where we invoke the set interval function, which is our animation loop that happens about every millisecond. It's already just built into the JavaScript. And then each time we're going to clear out the canvas completely. We're going to redraw the boundaries around the edge of the canvas. We're going to animate the ship, which is to move and draw it, animate the bullets. And so this gives us a little preference for the position of the ship and the position of the bullets, making it harder for the asteroids to get out of the way, or easier for the bullets to hit the asteroids. If a collision, then we're going to check for the collision up here. Now, one thing that we can do too is we can press the escape button to stop playing, and that sets the game state to ready. Also, what it does is it, notice here we are setting, when we're invoking the set interval, what the set interval function does is it returns an interval ID. So then with this interval ID, by applying the clear interval and passing it the interval ID, we stop the iteration of the set interval. And so essentially stop the game, and the escape listener has set the game to ready. And pardon my computer, it sounds like the disk drive is having some problems there. Yikes. I increment the score. The method to increment the score just does that. It takes whatever the score is, adds 10 points, logs it, and writes it out to the HTML, to the inner HTML. We've got up above here, we got this my score reference somewhere. To the HTML. Where did it go? I lost my reference to the HTML, but so there's quite a bit of code. I think it's on here somewhere. It's got to be. Anyway, so we write to the inner HTML. Then we do. So here's our functions for. We have to get an X or Y position that we use for the ship and the asteroids in the creation. We pass in the type of coordinate, X or Y, set up the variable, and then if it's an X coordinate, then the value that we pass into the random function is the width of the canvas, so it can be up to that wide. Same thing if it's the height, if it's a y coordinate, then we'll pass in the height of the canvas and then return a random number that references the canvas dimensions. So for a random size, we don't need to care about that. We can just generate based on the size that we want. So for the asteroids, what we're going to do is say the maximum size is 60, the minimum size is 10. So to do that, we generate a random number between up to 50, and then we add 10. So the adding 10 is what gets us the minimum size of the asteroid. And again, this value goes to applies to the radius of the asteroid circle. Then for clear level, which does our maintenance of the asteroids loop, we're going to loop through here, loop through all the asteroids. I'm going to take each asteroid and see if the value of show is set to 0. If it is, we're going to remove it from the asteroids array using the splice function. And that's just going to, because the ID is going to be the same as the position in the array, and we're just going to splice it out and just splice 1. If the asteroid's length is 0, that means the level is ready to be reset. So we increment the level, which means now we're going to have faster asteroids, and we're going to have an additional asteroid for each level. We clear out the bullets array by just making it empty here. So that'll give us clean slate to start from, give a bonus for completing a level, and write that bonus out to the score. Something in here isn't quite working right, but all total, it's starting to kind of approach a playable version of where it relatively nicely, I think, kind of mimics the play of how Asteroids plays. And then I can see if I can, ooh, just barely missed it. So I've been having fun. My kids have been having fun with this. And thank you very much for a great class. I learned a ton in here. It was a lot of fun.